We worked in a group of 3. My name is Meher. I'm passionate about business and fashion industries data.
Hi, I'm Nelson. I'm passionate about the science applied to marketing and finance and also Dungeons and Dragons.
And my name is Kilmi, and I enjoy the process of creating Lego puzzle from scratch.
So this is the website that we are using for the e-commerce. And let's say I want to add some headphones. I'm going to click on headphones and then let me add some items to my cart. There you have the feedback. And now you can also see that in your story you have view headphones and you also cart headphones, which means that you view the product and you also add it to the cart. If I buy them, now in my story it's going to say that I purchased it. So let's say I go back and I want to look for some electronic clock phones. So now you can see that here we have the recommendations based on this electronic Apple, and here we have the recommendation based on historial. In historial being that we search for products, electronic headphones, and also clocks. We can buy things here or see similar products, electronics, and then we have more recommendations. And if we like something, for example, let's say that based on my story, I kind of like this, I can add it to my cart and buy it. Then the recommendation engine is going to, based on my interactions, is going to create this list of recommendations. And you can see also that the banner changes, that's searches. You can see that it's kind of targeted toward what more likely I'm going to be looking for next. And here we can see the different categories.
Motivation of our project. Online shopping is one of the highest global growth sector right now. As you know, COVID-19 has changed the way the world operates. The new normal has dynamically increased in online shopping. Since the countless transactions are safer and lockdowns has given people no option but to use online platforms to purchase materials. Still, as the customer experience, the convenience and safety of online shopping experience, they're very likely to continue this again and again. Here is a graph of e-commerce growth from 2015 to 2021. As you can see that it's been increasing linearly since 2015. International shopping is on the rise. So if you take a look, Asia has the highest e-commerce growth rate, which is 63.4%. And according to the graph, it shows North America has the lowest, which is 45.5%. These are the most benefits of using the e-commerce sites. One, you could save time and efforts. Two, you can get detailed information about the products. Three, you can compare various models or brands. Four, you can have a lot of good deals and good prices. This is the data analysis part of our project. As you can see, we have data cleaning part, and then we figured out different data points from the data set, and then we have come up with these important and cool graphs. We have used Jupyter Notebook to analyze the data, and we have used Python. This is like overview of our project. As you can see, we have customer view and companies view. For the customer view, we have e-commerce platform and the recommendation engine. And for the companies view, we have top customers list, companies ranking, and customers behavior. These are mostly from the data analysis. Now Humin is going to take over and I'll walk you through the data visualization part.
In our project, we have interactive data visualization web application for represent our data analysis. And we have a full-stack web app, which is our e-commerce web app, which is built by React and Next.js. The backend API store our data used for our recommendation systems. We got the dataset from Kango, which is collected by OpenCDP project. And the dataset contains e-commerce behavior data from multiple categories store. And the most important column we use for the analysis is customer behavior event type. And there are 3 event types: view, cart, and purchase. And the width of the view is almost 96%. Here's part of our visualization based on the dataset. As we can see, there are top 10 brands that most customer purchase and viewed. So as we can see the different results between view and purchase. When doing online shopping, it's more convenient for searching different products and easier to compare price and option from different retailers and find the best deals. And here's the pie chart for top 10 category and most customer purchase and viewed. And also we can see the difference between the 2 event types. So to sum up, when doing online shopping, because it's convenient to compare different products, so it's also cause some trouble, like people may difficult to make a choice. That's why we're creating a recommendation system for support customer to make a better choice. And Nelson will introduce more about the recommendation systems.
Okay, so we created an e-commerce site where we can try our recommendation engine. So the e-commerce site has all the functions that a normal e-commerce site will have, like you can add things to the cart, buy things, clicking different products and see categories. So based on your activity, you are going to see dynamic banners, which means that depending on what you browse or what you add to your cart, you are going to have different banners displayed here. You're also going to have what other users searched for. So if, for example, if you search for a toy, you are going to have other toys, and this is based on a machine learning model, which takes a historial of previous users and then it recommends based on that. And you also have the based on historial, which means that based on historial, it recommends you certain products. The difference between these two is that this is based on the product, and this is based on all the products that you visited and you added to the cart or every interaction that you had. So for scrapping images, we had an algorithm, and the problem that we had just by imputing the problem that we had to scrap images is that we didn't have a product name. We didn't have the brand and the category code. So what we did was we will append the category code and the brand them, and then removed all the special characters like dots or slashes, and then make like a search like this. So you can see that here that's electronics dot smartphone Xiaomi will be converted into electronics audio headphone Xiaomi, right? Which is the category code plus the brand. Then you had the problem that for shorter words, for example, right? So one of the products brands was Creed, and this was a very short word. So if you were to search Creed in Google Images, you'll have more general definitions. In this case, Creed goes associated with a movie. So in order to find the product for Creed, we made the program detect if that was a short word, and then append Amazon product and plus Creed. And here you can see that at least you have some products as images. So all these images were scrapped using Google Images. We had to manually scrap them using a bot that went into Google, searched a certain query, and then downloaded the first image. So the algorithm that we are using in order to create a recommendation engine or recommendation system is collaborative filtering. And the basic idea of collaborative filtering, or this works based on the assumption that let's say if Tom likes bananas and apples, then and Jane also likes banana, then it's very likely that Jane is also going to like apples. The idea is that there's a common pattern between users, and the machine learning tries to figure out those patterns. So here we have a collaborative filtering example, and the idea is that we have this is an example using Netflix recommendation system. So the idea is that you have different movies and you will have different people, and everyone will rate movies differently. And the idea is that the machine learning will find the patterns between these users and then figure out or guess what users will rate a certain movie for. This methodology works by looking up the rating patterns of the active user, and then using ratings from like-minded people, it creates these latent features, which it figures out which patterns we like. So the idea of latent features is that instead of categorizing the movies into, let's say, a Harry Potter would be something like adventure, magic, then something like this for the Lord of the Rings will also be something like magic and adventure. Instead of categorizing it into human words, the machine learning will create its own categories, which will be these latent features to use in order to categorize these movies or to tag these movies. So it will help him define these common patterns. So this is how we applied it to our e-commerce site. The problem with our e-commerce site is that we don't have ratings for products, but we have interactions, which means that we have interactions like adding things to the cart, viewing products, or purchasing. Since we didn't have like a scoring or like a rating, the idea was that we will assign a score based on the aggregation of that user activity, depending on that user activity, right? So for example, let's say if we map cart as free, view as 1, and purchasing as 10, we will aggregate these actions. So if I were to view headphones twice and purchase it once, then it will be 2 plus 10. So 1, 2, and the plus 10, and that will give me a score of 12 for the headphones. And if I'm looking for notebooks, then I will view it 1, and here I'm adding to my cart, and that will be 3 plus 1, and that will be 4. So this will be your approximation or an idea of getting a score in which we can use to later create an algorithm to recommend things, right? So now if Huimin goes and builds a notebook and then adds it to the cart, it's going to have a similar score to me. So the algorithm is going to find a similar user like me, and then the algorithm is going to be recommending the headphones, right? Because she had these similar interactions or these similar scores. Now here is a little more complex example, and the idea is that if let's say that the algorithm can only recommend one product, we have the recommendation engine rate what is statistically more likely to happen, right? So let's say let's say I have a score of 4 in laptops. Maher has a score of in 4. This guy also has a score of 4 in laptops. But I will have a score of 12 in headphones, and this guy will also have a score of in headphones too. However, Maher has only a score of 0 here, but she has a score of 1 in apples. The machine, the recommendation system, if it can only recommend one product, is going to suggest the headphones instead of the apples, because he sees in the relevant users that it's more likely for us to purchase a headphone than an apple. And this is calculated by just doing a mean, what is the largest mean in each product. So this is our API documentation. You can play around with it. Things you can get from here are the banners and every product recommendation. The banners are actually created by Maher. What we did was we figured out which were the most popular categories, and then based on that we created 10 banners. We didn't spend that much time on creating banners. This is just a proof of concept. So you can actually hit all the banners here, and that should be here. And you can get all the available banners, and these are actually sorted by which one is more popular. So if we want to get the popular products, you can see that every product is from a different category. So you don't have like 2 computers or 2 kitchen kettle mark. To do that, we have an API over here, and this actually gets the most popular product for each category. So if I limit it to 5, it's going to provide me the top 5 most popular categories, and it's going to, for each category, it's going to give me the most popular toy from it. The other thing you can do is, for example, the historial. I can go on top here, copy this, paste it here, and you should be able to see the history of that user. If you paste like invalid, of course, ID won't show anything. Every time you refresh the site, the historial changes, you can see. Now this should be empty. It should be empty, but if I go and play around, let's say I want to add some items to the cart, or I want to see my card, purchase those items, and if I refresh this, I'm missing a 1 here. If I refresh this, I should see all my interactions. Where you can see that I'm viewing my headphones and I am looking at my audio headphones. So we can see the Slack ID, so we can actually have an API to get the product details based on the Slack. That collects the information based on the Slack. And if I copy enter that one, you can see the details about that. Oh, sorry, this one. We copy this product ID from a bicycle, and if we go to the detailed products, we should get this product line over here. We paste it here. You can see that now it's recommending these products over here. Bicycles, other bicycles, other people viewed. And then based on historial, we can get this based on historial by copying our session ID products. We paste our session ID. We write how many recommendations do you want to have. This usually takes a while, but it's fairly fast. And you can see that these are the recommendations based on all my interactions, right? This is the Streamlit application. This is more like for data visualization. You can play around with the graphics and look at the changes over time and figure out different distributions, as well as to check for data frame or examples of it, and provide an example of how different. Here we have our social media. Please contact us. We are looking for jobs. Thank you.